time to start the actual content on the course. So the first lecture is asking the question, what is artificial intelligence? And I would be super happy to give you a one-slide explanation on this is AI, this is what we're going to go with, and that's it. But there's more to it than that. And you will see why. So, the outline for the next 1 hour and something will be that we try to look at the big and maybe a bit bold picture of AI. Like intelligence, being then artificial or not, sounds quite impressive. I'm going to take you through some historical perspectives of AI for you to understand why it's a bit complicated when it comes to defining AI. And that kind of helps us to gradually narrow down what AI is all about. And I hope we arrive at some conclusion that we have, or you have, a picture of what AI is. And after that, we are going to play this game about examples of AI and discussing a bit whether they are AIs or not. When I was preparing these slides, it was pretty hard to come up with things, what you should visualize, in some cases. And that's why in some cases there's a random image or a picture or a selfie or something on the slides. You will see, it's just to keep you awake. I think it's actually pretty easy to tell someone what artificial intelligence is. I would say that humans and animals have real intelligence, and machines have what we call it artificial intelligence. Of course, this is not very helpful, but if someone asked you what AI is and you just want to get rid of them, this is a good way to start. The other thing that I want to highlight is that AI is not about computers. AI would exist without computers. It's more about adaptation, learning, and decision making. But computers will have a role in all this. Another thing, I'm not telling you what AI is not, and I can keep going. AI is not food. AI is not, well, but then there's some misconceptions that are very commonly there, and that's why I want to highlight some of them. So AI is not just about computers, and AI is not equal to robotics. So, yeah, here's my friend. So artificial intelligence is not robotics, but even robots can use artificial intelligence. It's a bit like if you think of yourself as these meat skeletons that are navigated and controlled by some intelligent entity, which is your brain, you could think of the relationship between a robot and AI in a similar way. But still, I would say that AI is maybe more concerned with the person here than the machine itself. Where does all this start? And this is the selfie part. I couldn't figure out what to put here, so I put the selfie. Works always. So artificial intelligence is based on the assumption that the process of thinking can be mechanized, turn into something that can be presented in a formal way. And this idea is actually really old. There's some great thinkers, philosophers that kind of developed these structured methods of formal deduction already way back. This predates mechanical computing devices or computers were like thousands of years. Of course, it's not been so that things happen like this. It's been like a slow trajectory, slow path that have led to many advances over the years. So those advances being like typically in like philosophy, mathematics, physics, and so on. And for example, like the 17th century philosophers considered that all rational thought could be made like systematic. Systematic in the same sense as algebra or geometry. So you could really like kind of dissect the process of thinking into some like bits and pieces that you would then like kind of like go through, and that would be kind of the thinking process. So these ideas are kind of old. So where do actually computers come into picture? There's this kind of like statement, or like it's called the Church-Turing thesis. And Alan Turing will be a recurring name in the next slides. And this thesis says that a mechanical device shuffling symbols as simple as zeros and ones can imitate any conceivable process of mathematical deduction. And if the previous thing said that thinking can be reduced to kind of this formal mathematical process, and then this says that if you have some device, be that then a mechanical device or an electronic device or a physiological device, if it can then actually imitate any process of mathematical deduction. So you just start with very simple building blocks and stack those simple blocks into something more complicated. Like this like house of cards kind of thing. Then you can actually make up something very complicated. And now, well, this device here is not that complicated. But if you think of such a mechanical device that would have an infinite number of cogs and wheels, then that in theory could generate cat pictures for you in the best case. Okay, so where do computers actually come into picture? We could build a mechanical device of those cogs, but then actually to represent these like modern day AI methods, say I would like to run ChatGPT on this mechanical device with all these cogs, that device would need to be huge, like planetary dimensions huge. And we cannot build mechanical machines that big. So that's why we need other means for this. And this is where computers come into picture. What does the word computer actually mean?
On this basis of this picture, perhaps it's the people that are computing.
Yeah, it's something that computes. That might be a device, that might be a person. And actually here, this hall, this is the computing division. These people are computers. That's their title. And if you read really old scientific publications, like, well, not really old, 100 years old. That's not that old. I just thought about Greek philosophers. But we go 100 years back. The paper might have like a statement that take this equation and give it to your computer, who was actually a person. And of course, then kind of like modern day computers, they split big problems into smaller chunks and then run those in parallel, and that's what's happening here as well. So these computers might be working even on the same problem, they are just split it into smaller parts, and they collaborate. And yeah, they're probably doing a great job. But also this, if we would like to generate cat images with a neural network, that would require a lot of people doing the computing. So that's why we are lucky to have different types of computers these days. And this is an early computer from the 1950s, the first half of the 1950s. And it's like room-sized. and it's probably doing some fancy things, but it wasn't that efficient back then. And of course, nowadays, probably my smartphone is like 1 billion times more efficient than, like, have more compute than this computer. But this was the first step, and we are going, like, taking small steps since, and which has led us to having these monsters that I have here in the front, but also then like a lot of other computational hardware. So the computers are there for a reason, because implementing these AI methods that we will cover in the later lectures, that will be pretty hard without the compute infrastructure we have these days. Okay, so let's say we now have some device that can run the AI. We can put the artificial intelligence on one of those machines. How do we know that it's an AI? That's why we have something called a Turing test. This is like one view on the thing. And the test is pretty simple. We have an interrogator. That's this person here, who is using their phone, in this case, to communicate with two players, A, who happen to be a real intelligence, and B, who happen to be an artificial intelligence. And the interrogator can communicate through like chat messages or over the phone or in some way with these two players. And if the interrogator cannot tell them apart, then the AI is said to pass the Turing test. So this is called like the imitation game. Can the AI imitate a real intelligence? And this was something that Turing proposed in the 1950s, and it's basically kind of a test or an idea that a machine's ability to exhibit kind of intelligent behavior is kind of defining whether it's actually a kind of an artificial intelligence or not. And yeah, the human interrogator interacts with two players. If the interrogator cannot determine which player is a computer and which is a human, the computer is said to pass the test. I gave this course for the first time in 2019, I think. Yeah, 2019. And believe me, things have changed a lot in these years. And that's why I think it's quite interesting to look at what we kind of had in around that time. This is already kind of like 5-6 years ago. And this is from announcement from a kind of like a Google event where Google is showing off the capabilities of the Google Assistant. And I'm going to play this video. Let's get back to this then.
So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and noon. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
How can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like. What service is she looking for? Just a woman's haircut for now. Okay, we have at 10 o'clock. 10 a.m. is fine. Okay, what's her first name? name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks. Great. Have a great day. Bye.
How many of you have an Android phone? Are you using this functionality on a daily basis? Yeah, I understand you. Yeah, so this was like 6 years ago. And this is still not kind of something that we would be using. But actually in 6 years, a lot has happened. This was like super impressive 6 years ago. But now I think this would be actually quite easy to build up with the APIs and tools that are readily available nowadays. Of course, it would be a kind of a mess, but probably something that would be that hard to build. I was thinking about this morning while driving here, and I activated, there's this functionality in the ChatGPT app where you can actually like interact with ChatGPT in a natural conversation. And I activated that so that I could like speak freely in my car, and I was driving. I was on the ring road, and I asked it some things that I need to know, and so on. It actually worked quite well. And it kind of reminded me of this, because it's actually like a natural conversation. And I was quite impressed until it suddenly misinterpreted something that I said, and it switched to Arabic, which was super scary. Someone's screaming at me. Well, probably not screaming, but then I couldn't understand anything, and it just kept coming, and I couldn't understand anything what it was saying, and I had no clue how it switched to Arabic. But clearly, it's not quite there yet.
Which version was it? ChatGPT, which version?
I guess it's ChatGPT, the GPT-4 model that it uses.
Are you using the free version?
No, this was the paid version.
So it's for
Yeah. There's another way of looking at how to classify AIs as well. So the Turing test is one way, so that if the AI can actually like appear intelligent, if it can trick you, then great. Then it's passing the Turing test. There's something called a Chinese room argument. And this is kind of a counterexample to the Turing test. It basically asks that can we recognize AI when we see or meet it? A simplified version of this argument is that you have an AI that is in a box, and it's been trained to respond to messages written to it in Chinese. So you can write, if you know Chinese, you can write in Chinese and pass the messages into the box, and you get an answer, you get a message coming out from the box, and if it's trained to do so, cool, but it can be trained to respond to any type of message without actually understanding Chinese. So this kind of counterexample is that even if it appears intelligent and kind of makes an impression of being intelligent, that doesn't mean that the method or AI actually has a mind or is conscious of some kind. It can just be trained so that if you feed it this type of input, then you get an output. And if you've ever interacted with these GPT models, that's maybe something to think of. So it's really like an input-output type of interaction that you have. Well, this kind of brings us to types of AIs. A strong AI really is intelligent, like you or me. But a weak AI is said to act intelligently. And all the AIs we have today are weak AIs. They, at the best, they act intelligently. We can also look at something called general AIs. It's called like artificial general intelligence. An AI that can handle any task. A bit like you. You can learn to drive a car, cook food, do sports, write a book. Like the world is your oyster. But AI methods, they are built and tailored for specific purposes. It's not the same AI that generates text and understands images and so on. It's kind of like a mixture of different components that are tailored for specific purposes. A narrow AI can handle one task, kind of a specific task. And these are the AIs we use. Even if some models might be multimodal, they can take in images and text or audio and something else. But they are still narrow in the sense that they have been tailored for a specific task, trained for one purpose. And not so that they can just decide that, screw this text generation, I'm going to be an architect. So they are really narrow AIs. So it feels a bit kind of like grand to directly aim for like human level intelligence. So we should maybe take baby steps instead. I'm going to go through some of those baby steps next, but let's have a short break. 10 minutes, be okay? Loading. Yeah, let's continue like, I don't know, 12 past. Let's continue. So instead of aiming for like human level intelligence, let's go through kind of like a quick ride through the history of contemporary AI. I split this into kind of like chunks. And I call the first part the golden years. And that started kind of like in the 1950s and kept going on to the 70s. And this was an area of like reasoning and looking at reasoning from a point of view of search. Kind of making decisions is kind of like searching kind of a path through different options. And also, of course, when you start to design your own AI, you of course think that, well, I should interact with it, it should probably understand me and so on. So that's where kind of like natural language processing, like handling natural language inputs, kind of like understanding natural language. The field started with that. And of course, we had robots. So we want to kind of like build AI entities that would roam among us. It's like era of beginning of robotics research. And there was a lot of early optimism. People had they had these computers now, these digital computers. So then it felt that, well, we're just going to put the AI into the computer and that's it. And this is a quote from 1965. Machines will be capable within 20 years of doing any work a man can do. Well, didn't really happen. Or this is from the 50s. Within 10 years, a digital computer will be the world's chess champion. Well, that didn't really happen. And some of you are old enough to remember when it actually happened. It happened in the late 90s. And this was something that was like followed in the newspapers and so on. It's like a big thing. And it wasn't maybe that much kind of a victory of AI at the time. Maybe more kind of a victory of compute. The Deep Blue supercomputer won over Garry Kasparov in this series of chess games. But kind of like playing chess is kind of like a solved problem AI-wise nowadays, and also like playing many other games against humans. We are losing there, but we maybe still have skills that the AIs don't have. And kind of interestingly, I think it was just like after this like grand challenge of beating the best human player in chess that had been kind of like an ultimate goal for like almost 50 years in AI, people realized that it's maybe not like winning the game that is the hard part, but actually designing an AI method that could control a robot to grab the pieces. Because here, it was really some dude sitting at their computer and feeding in all the moves so that the Deep Blue could actually then like propose the next move. So it turns out that actually grabbing the pieces is harder than winning the chess game. And we have still not solved that. Well, the next kind of era in AI goes here under the title AI boom. This was a time of expert systems, kind of the buzzword of the time. Also kind of like knowledge in the form of that people actually fed in the data into digital form. This was an era of kind of financial and other data actually started to be available in digital form, which is kind of a prerequisite that you can actually train or interact with the data. And neural networks that had been kind of around since the 50s already, so they were kind of popular. It was like an active research area in the 80s. Then there's an era that I just call here AI. And, well, it took some like 40 years to finally have something that works. Some of the first goalposts set in the 50s were met. And like AI tools and products started to slowly actually appear as part of like products that people were using. They are still not great, but they were there. I remember like some mobile phones from the late 90s that you could control with your voice. It worked maybe 20% of the time, but it was pretty cool. And of course, AI has not been developing in a bubble, kind of, but actively interacting with other fields of science. And clever engineering has brought us like faster and more capable hardware to implement things on, and that's also one reason why, for example, the methods won Garry Kasparov in chess in the 90s. And then like agent-based systems and all these things that every decade has its own like buzzwords and things going on. Then moving to kind of the present. And I call this now the big and deep era. And that's been going on for roughly 10 years now. Where kind of the buzzwords have been like deep learning, kind of advances in deep, kind of like layered artificial neural networks, finally kind of made some breakthroughs in working with like natural data. And by natural, I mean kind of chaotic data in the same sense as the world around us is chaotic. Images, text, audio, things that we can process without problems, but actually it's very hard to process in a mathematical sense. Big data was like a huge buzzword some years ago. And it's kind of important because without the data, it would be very hard to train these machine learning methods that are very much now in the news and everywhere. And finally, like AI and machine learning start to be kind of mainstream. These aren't something that are just like research in labs, but the things that people actually use. Some things are things that you realized are there, but there's also a lot of machine learning and AI methods that kind of like work quietly in the background. For example, in the phones, kind of controlling screen brightness, battery like optimizations, and so on. The history of AI, as you could maybe tell from that there's been kind of these different waves. It's been pretty bumpy. And the reason for that is that if we plot time on the x-axis and like progress, what that ever might mean, on the y-axis, we have seen kind of these things that something has, there have been advances, new innovations, more data, something fundamental has changed, and there's been kind of like progress happening. And when that happens in AI, people start expecting a lot. You could tell that from the quotes from the 1950s and 60s, that, well, in 10 years we're going to have flying cars. That didn't happen. And AI has been going through these hype cycles, that when something kind of like starts working, people are expecting stuff kind of right away. And that has kind of led to this sort of weird phenomenon that there's been like advances, people start expecting things, and when the gap between the expectations and the reality grows too big, then people are disappointed that, that AI, it doesn't actually work. And that's been happening several times over the history of AI. And, well, we are here now. And people are expecting a lot. And I think the field has been delivering. There's been constant advances. Every few months there's something impressive coming out. And then the news call me again, and then I comment on things. But it might not be going on forever like this. And the periods in between, kind of like the low points of the hype cycles, are called AI winters. And these are the times when people are disappointed in the progress, which leads to people thinking that, well, it didn't really work out. And then there's funding cuts. Let's not fund that. It didn't actually work out, which slows down maybe like progress because there's less people in AI and so on. And this has been happening many times. And the consequence of this is that people in AI are very often not calling themselves like AI researchers. They call what they do something else. They call it informatics. They call it machine learning. I'm a machine learning person, by the way. Analytics, knowledge-based systems, business rules management, cognitive system, intelligent agents, computational intelligence, and so on. And this is partially to avoid the stigma of like false promises attached to the name artificial intelligence. And telling you this now, when we are at the high point of the hype cycle, is maybe a bit weird, because now AI is very fashionable. But there might be new AI winters coming. Brace yourselves. AI is pretty much everywhere nowadays. At least people like everywhere are interested in using AI. And I must say that just in the past 10 years, it's actually been sort of like creeping its way into a lot of things. Kind of slowly, but steadily. Be that then like health, natural sciences, arts, whatever. So AI is there already in some form, and people have a lot of interest in leveraging AI tools. So why is AI hot now? I think that people see real impact. People can actually try out these tools. They might actually see that there is something going on there. It's also so that the time to product is shorter. When there's something there's some innovations coming out, it doesn't take that long for people actually to be able to use that. And what is helping this? Well, the compute and infrastructure is kind of already there. Say, Apple ships a new version of their operating system with some new fancy things. I already have a phone that can run that. Or then you can just access things through your web browser and run things in the cloud. You don't need to buy a new computer when a new version of ChatGPT comes out. Is there hype? There's thumbs up there. I see some nodding there as well. Yeah, I think most of us agree on this. I think there's a lot of hype going on in AI. We'll talk about the hype on the last lecture. Like there's a lot of snake oil, hot air, and so on. But also then like the hype is kind of also there for a reason. But there is definitely hype going on. And who is feeding the hype? I think there's real progress that is feeding it. But also a lot of people who don't actually understand AI, who are feeding AI. And I would say that there are a lot of people who also know AI, who are feeding the hype. I think, this is my personal opinion, that OpenAI is really good in their kind of like publicity management. We'll go back to this in the exercises, but they have kind of building up this sort of then like thing over the years. That first they announced that we have an AI that is so dangerous that we aren't going to publish it. And then they get a lot of media coverage. And then there's roughly a year, and then they make it available that now the dangerous AI is $20 a month. And of course everyone is interested. And then they kind of like been doing this for other things. And kind of it's a way of kind of their marketing, of course. And it's a company. So I think they're doing a good job in that sense. And they have a really strong team. So let them do it. But we should also be aware of that. There's a lot of marketing involved. So I've been talking now for almost 2 hours, and I haven't actually tackled the question of what AI is. And partially because of the historical hype cycles and false promises and so on, there's not really an officially agreed upon definition. And on this course, I will try to consider AI in very broad terms. I could say that AI is a system that can show adaptation. Or one could say that AI is something that provides you with additional information that helps you in decision making. This is very hand-wavy. So what people often want to say that, well, method X is AI. People say that, well, ChatGPT, that's AI. Or Siri, that's on my phone, is AI. But AI is not really about specific methods. I would say that AI is about problems. Problems meaning that how to make something happen or something work. How to make computers understand natural text. How to make computers recognize cats in photos. How to make a car drive on its own. And so on. How to make something happen that we perceive as something that requires thinking. There's something called the AI effect. the AI effect means that the field has a tendency to redefine AI. So once something starts to work, then there's someone like standing up and saying that, but that's not real AI because of something. So that's kind of like leads to defining AI as something that has not been done yet. AI is something distant future that we don't have at this time point. That's the AI effect. Good example of this is autopilots in airplanes. You know, you fly to, I don't know, you fly to Paris. So I think most commercial airlines are actually piloted for most of the trip with an autopilot that monitors different sensors, knows the route that it's supposed to take, and controls the plane. And then the captain just sits there and oversees the autopilot. And the autopilot, that's kind of control engineering. That's a great feat by control engineering from like the 60s, 70s, and so on. And like I would say that flying an airplane, that's pretty damn hard. And if you have some method that can fly the plane from Helsinki to Paris, that's just like really good. Clearly AI. But no, that's clearly too easy. So yeah, no, that's not AI because it's solved. Yeah, because we can do that. It's definitely not AI. But on this course, I would say that that falls under AI. So well, once something works, people claim it's not real AI. One reason for people having so high expectations for AI is that everyone kind of knows what AI is. Because we've seen it so many times. We've seen it in books, comics, movies, you name it. And it's also a bit kind of difficult being a researcher in AI because kind of everything has been invented. So now it's just like my task to actually make it happen. Make it work in reality. So people have so many kind of different expectations and beliefs of AI based on movies, for example, that it's a bit hard kind of discussing AI with kind of the general public. People are asking of Terminators. Talk to a journalist, Terminators come up. It's also a bit hard for us humans to understand what is actually difficult because we are kind of hand-tailored to navigate and live in this world. We make decisions, we observe our surroundings, it's kind of effortless for us. But many things are actually quite hard to make happen in AIs. And we will dig into this in the next lectures. But say, making an AI that follows the rules of a game to play chess. It's kind of something that you can easily write down in mathematical form. But try to write down an equation that describes a cat. That's hard. I know a trick or two in mathematics, but I have no clue how to describe a cat with an integral. I'm arriving at some definition of AI. And luckily we have the European Union. Because the European Union has been discussing AI and how to govern the use of AI. And in order to discuss something, it needs to be defined what they are discussing. So they have spent a lot of effort in coming up with a definition. And the AI Act is what is coming out from the Union. It's kind of their great achievement in governing the use of AI. And this is from the AI Act that was published just recently. So, an AI system means software that is developed with one or more of the techniques and approaches listed in Annex 1. We'll go into that in a bit. And can, for a given set of human-defined objectives, generate outputs such as content, predictions, recommendations, or decisions influencing the environments they interact with. And earlier versions of the AI Act had more hand-wavy and maybe more general definitions, but they went into quite specific ways of defining things. So Annex 1 lists that machine learning, including supervised and unsupervised and RL, falls under this. We'll look into this next week. Our logic and knowledge-based approaches go into this. This will be the second last lecture. Or then, this is kind of orthogonal to the two first bullet points. Statistical approaches, such as Bayes estimation, search optimization methods, also fall under this. So this is like really specific, but I understand that they will want to know what they are controlling. Of course, this is the definition by the European Union, and if you ask some of my colleagues, or I don't know, someone on the street, they might disagree, and this is still not something like widely accepted, but maybe something to start with. A lot of terms were mentioned: logic and reasoning, planning and optimization, and then machine learning. And this kind of blob, if the big blob represents AI as a whole, then you can like see these subfields within AI to be present somehow. And of course then things like data science or statistics kind of overlap with this quite a bit. This is something that I spotted on Twitter. So the difference between machine learning and AI. If it's written in Python, it's probably machine learning. If it's written in PowerPoint, it's probably AI. And, well, there might be some truth to this, because AI is kind of a buzzword. And many of the things you read about in the news are kind of machine learning methods that are often implemented in Python, to be frank. But AI is something more general than this. So, yeah, take this with a grain of salt. Good. We have some good 20 minutes to go. And it's Friday afternoon, and some of you are dozing off already, I can tell. Maybe we try to look into different things. So let's say this is kind of like AI, but like defining by examples. How does that sound? There's some thumbs up. Yeah? Do you have an idea of what AI is now? Not really. Me neither. Yeah. Yeah. It should be slightly unclear. And let's keep redefining that like every year. So I'm just gonna like throw out different things and let's discuss. Okay. Yeah. I recently ended my subscription of Netflix because the content, yeah, this is a screenshot from my Netflix. Is there any AI here? Why? Why not? Yeah. In the front, maybe, yeah. Not here.
There's an algorithm to recommend you what to watch next. And maybe there's an algorithm also to present what it's featuring, what are the topics.
Yeah, so I'm just repeating the answer. So, like, recommendations, yeah? These are like the ones that are being recommended for me here. probably because of what I've been watching before. Recommender systems. Is that AI? Who thinks recommender systems are not AI? A handful. Who thinks recommender systems are AI? Yeah. I would say that recommender systems definitely go under AI. Yeah. Something that can be used as a decision-making tool or aid. It's helping your decision if you just like superficially look at it. Yeah. But also then technically, I would say that it's learning, adapting, AI. Are you agreeing now?
Initially, I was thinking like Netflix, like okay, I watch a movie and then it has like I don't know 3 genres in there, and then a single code could just put it in a list and then just statistically say, okay, this is the most specialized. And I didn't think that was very much AI-ish, but then there's statistics there, so kind of yes.
Yeah. So it doesn't need to be fancy to be AI. It can be very simple. It could be a simple like if statement. If you have watched this, recommend this. That will still actually fall under like the characterization of AI. Maybe not that exciting, but it will still be there.
But you don't need to follow the recommendation if you don't buy the premise that somebody can
Yeah.
recommend something based on your statement.
So if I recommend you to watch Peppa Pig,
I won't.
yeah, you won't. Yeah, but I'm still recommending that. Yeah.
I control.
Yeah. Okay, I'm just like shuffling through my apps on the phone. This is from the Photos app. And is there any AI here? I see some nodding. What type of AI? What would be the AI aspect to this? Face recognition. It recognizes the faces, and also it tries to recognize who's in the face, like whose face it is, to kind of like make this library of like pictures of me. And there's, I'm not going into details, but there's like a method that has been trained to kind of like map the faces to this space which is kind of like head pose and hat invariant, that they can kind of like recognize me both with glasses and without glasses and so on. So there's kind of fancy things going on under the hood. This is from Siri, the voice assistant. Is there any AI aspect to that? I see a lot of nodding. Is there someone who thinks there's no AI involved? No one. Okay, but what is the AI there?
It's the NLP. It's
NLP.
processing audio of speech.
NLP, I would call it kind of a system, because there are several blocks of AI. Because first, when you speak to your phone, then it needs to kind of like decipher the spoken language into something that can be actually processed by the next step. So it basically turns the speech to text. Then there's a separate block that goes through the text and then like interacts with you after that. So there's like a chain of different blocks and different types of AI as well. So it's kind of a system. Okay. Next app. That's from I think that's Apple Maps. Anything AI about this? Not really. Could there be something AI-like in the Maps application?
Perhaps again some recommendation as like you take this route every day, but this route is more scenic, so like Waze, for example, has 3 different usually routes you can take. It's like a bit faster, but this one here doesn't have accidents, and it has to think to know, okay, there's an accident, make it that.
So like routing route finding actually is a very classical thing. Because kind of like, you know that I want to start here in Otaniemi and I want to drive to Seinäjoki or Tampere. Then there's a whole lot of decisions you need to make along the way. There's a lot of routes that can take you from Otaniemi to Tampere. But then finding like a good route in some sense is actually requiring kind of search and maybe some knowledge, kind of like an informed search, so to say. We'll go into this on the 5th lecture. That's the compass application. Is that AI? I guess the compass itself is maybe not AI, I would say. Even if you're very like accepting here. We accept all kinds of AIs are welcome, but the compass itself is maybe kind of like not an AI. But knowing that the sensor actually needs a lot of calibration and so on, so there might happen a lot of smart things under the hood to make the compass sensor provide you some useful knowledge. And that probably involves learning the bias parameters of the sensor. So even there can be AI methods under the hood, and there actually is. The weather app. Now you're suspecting everything is AI because you're on an AI course. Yeah, maybe the weather app, like the app itself, it just displays the information, I guess. But weather prediction, then again, can use a lot of different AI tools. Of course, like most weather prediction is based on like physics simulation, but then there's a strong interest in using AI tools to improve weather prediction. Is this AI? Is that AI? Why?
It recognized everything, the doorknob. The robotics itself is not. The motors are not AI, but the camera that sees the doorknob instructs the robotic arm to go there. That's it.
I'm always very suspicious about the Boston Dynamics videos. Because it could also just be pre-programmed, and they just film it 1,000 times. I don't know. But even if that would be the case, there would certainly be a lot of AI methods just to like adjust for all the sensory information and like to keep the robot actually like from like tripping over and so on. And I believe that you're correct. There's probably a lot of very fancy things going on here.
I mean, there are retakes also in movies, but you don't doubt that.
Yeah, I think there are a lot of retakes in these videos, but they are very impressive. This is from an art piece, and I'll just show you the description. So this installation, which was actually pretty fancy, is rendered in real time by a computer program. It is neither a pre-recorded animation nor a loop. The installation as a whole is in constant change. Previous states will never be repeated and can never be seen again. And you stand in the middle of all that. Is this AI?
I think the more interesting question is that art?
This is not the course to discuss that. Let's not go there. I think it's pretty impressive. I was impressed by this. So it's kind of like a generative model. It generates the art experience. And I think like generative modeling definitely falls under AI. So I would say that let's accept this to be AI. How about this? And now you need some more context. These are actually not real images. So talking of generative AIs, these have been generated by GANs. There's this web page that like thispersondoesn'texist.com that you can go there and it generates face images of people who do not exist. And this was the state of the art some years ago. Nowadays the models are of course even better. The same applies to these. Generative modeling, these are animals that do not actually exist. They are generated to resemble the data distribution that the model was trained on. And I'm no expert on animals, but most of these would actually like trick me. I would actually think that these are real cats, dogs, lions, and so on. So generative modeling, pretty much AI. Of course, then like it's been a lot of like writing in newspapers and so on about these like generative methods where you actually can control the output. So here, for example, this image has been generated from a prompt, a professor in a bow tie presenting to a diverse audience, hand-drawn sketch trending on ArtStation. And this is the output. Would that fall under AI? Yeah. Or then a painting by this grandmaster of Finnish art of an old man checking his smartphone. And probably no smartphones existed in the 1800s, but then the model has seen photos of smartphones. The model knows the concept of old man and what kind of the style of Albert Ehrenfeld looked like, and it can kind of like interpolate between these concepts to create something that was not in the training dataset. We talked about Alan Turing in the first half of the lecture, and this is Alan Turing, 16 years old. And, well, it's a photo of him. It's not AI. That's actually him. Now you're suspecting I'm trying to trick you with something, probably. And this is from the same photo. And we don't have a video of him being when he was 16 years old, but let's not stop that from us generating a video of him. Would that go under AI? Yeah, I would say so. Yeah, I mentioned ChatGPT a number of times. And now if I look at what ChatGPT is suggesting to me, I should go through the basics and definition of the history of AI. I should cover machine learning, NLP, robotics, ethics and social implications, AI tools and techniques, AI applications, and the future of AI. I think I'm doing a pretty good job. Or, yeah, I don't know. What do you think? I'll ask you in the course feedback. Is this AI?
Yeah, it's hallucinating.
Yeah, it could hallucinate. I think this is kind of like quite good. And it was pretty funny asking it before, like who I am. Because in the first versions, it came up with a lot of like hilarious things. But nowadays it's actually pretty good. It invents some awards and gives me some additional titles that aren't true, but it quite well knows what I'm doing nowadays. So it's a bit disappointing. I kind of liked it more when it was actually like coming up with. I was like an artist at some point, and like I've been many things. So, just to give you a recap of this first session, I've just tried to cover like a lot, just give you like a very soft introduction to a lot of hand-wavy stuff. So what to figure of all this is maybe that AI has come a long way. It's not something that suddenly materialized when OpenAI shipped ChatGPT. It's something that's been kind of like coming together over a long, long time. And it hasn't been an easy journey. And it probably won't be an easy journey in the future either. AI is very hard to define, and probably every expert in the field who you ask will give a slightly different definition. And that's just how it is. But on this course, we are very accepting. We think of AI in broad terms and try to more often like look at the big picture by zooming in into certain methods and applications and problems in AI. You saw different examples already here. And in the next lectures, we will dive into more how these things actually work under the hood. What are the building blocks? What are the assumptions? And how they can learn and show intelligence. Any questions about the first lecture? Nah, everything was clear. We will see about that when you answer the quiz questions. And they are maybe, some people have called them trick questions, but they aren't trick questions. They just try to kind of make you think back. It's not just so that it's some point that you open the slides and then like look up the answer. It's more actually probing your thinking a bit more. Next week, we will cover machine learning, actually dive into more specific things under AI. Before that, answer the quiz. The deadline is on Friday before the lecture starts. And the first exercise session will be on Tuesday. It will be in the undergraduate center. And Marcus will introduce the exercise. And then you can stay there and work on it. And there will also be me, together with other people from the course, the TAs, to chat with you, discuss these topics, and so on. The next lecture is on Friday in this same hall. If there are no questions, now is your chance. Let's end the lecture. Thank you so much.